Assalamualaikum warahmatullahi wabarakatuh and good day to each and everyone. So, last meeting we have already discussed the agent value problem in which the application in dealing with the matrix. Okay, so we have also discussed the vector differential calculus, and we have also given an example in which on how to deal with that different topics that we have already. So I'm planning to have our prelim exams these previous weeks, but since I have not enough time to cover that, okay, and of course we are since we are having to cover, no, we must have to cover all the topics that we have before we will first take the exam. So I decided to cover all our exams na lang sa midterm. So it means that um, since hindi naman gaano kuan kataas yung na-cover natin na topics, okay, so we will cover all the topics that we have from the prelim until the midterm exam na lang sa midterm exam natin. Okay, so please study na lang. Okay, so whatever you will be have in our exams, that will be your score in our prelim and midterm. So and of course your quizzes is very important. No? So make sure that you have already answered the involved practice problems here in our instructional materials. Okay, so right now we will be our topic for this day is vector integral calculus. So we are dealing with how to solve a mathematical problem by using integral calculus. So okay, so first is we have here the line integrals. So um, if you have a problem that deals with the integration of a function at a certain path, no, defined path. Okay, so we can use a line integrals to evaluate that one. So we have here the concept, we have here the line integrals. The concept of the line integral is a simple and natural generalization of a definite integral. So we have here defined by this integration, we have f of x dx uh, that is integrated from a to b, where that a to b is the end point of the path that we are specifying. So recall that in this equation, we integrate the function f of x, also known as the integrand from x is equals to a along the x-axis to x is equals to b. So since we are integrating here as a function of x dx, that's why in here we say that we are integrating that one as a function of x. So we shall integrate the given function, also called as integrand, along the curve C in space on the plane. So not this integral line integral here is not only specific on that path, but we can also use this one to evaluate the integral of a certain function in any path, no, in any path, not only in the x-axis, but um, all possible path that can be specified from one point to the other point. Okay, so that's why in here we are required to specify a position vector. We call this one as a position vector in order to um, in order to make sure the path, no, that we are dealing with. No? So we have here r of t is equals to x of t, y of t, and z of t, or we have x of t I plus y of t j plus z of t k, where t is from the path from A to B. So take note here that ijk here is the unit vector that we are having in dealing with the path, no, or vectors. So that is the unit vector in specifying the direction of the path. Okay. So we need that in integrating a certain function because um, take note that we are dealing here with the vector integral calculus. So it means that the direction of a certain function is very important in integrating it. So that's why we need that one. So the curve C is called the path integration. No? So if we have this path integration, or if we have this curve here that specifies from this point A to point B, okay, so we call that one as a path of integration. So the path of integration goes from A to B. Thus, R of A is the initial point and R of B is the final or terminal point. So C now is the oriented. Okay, so we need the uh, end point of we need the uh, end points of path to specify the orientation of the path that we are dealing with. The direction from A to B in which T is increases called the positive direction of C, in which we mark it by an arrow. No, so if you have to integrate a certain function, okay, along the path, so you need to specify its direction by using this arrow here. No, same as this for closed path. Okay, so the points A and B may coincide as it happening in figure 2.19b. So we call that one as a closed path. Okay, so if you have a path that is start from the same start and end at the same point, so we call that one as a closed path. So usually we are also dealing with that one. So C is a is called a smooth curve if it has each point unique tangent whose direction varies continuously as we move along C. Okay, so we note that R of F or R of T in this equation 2 here, R of T is differentiable in its derivative. Okay, so ibig sabihin, its derivative with respect to time is defined, no? So hindi siya nag-equal to 0. So, okay. Now, we have here the definition and evaluation of line integral. So, for us to be able to perform a line integral, we need to define it first and evaluate it. So, a line integral of a vector function f of r over a curve c that r of t is defined by that one is this defined by this equation. So, we have here um, the closed integral of function f of r uh, dotted with the infinitesimal displacement, okay, along the path of curve C is equal to f of r of t that r prime of t dt that is also integrated from A to B, where A to B defines the path C. Okay, so take note here that r prime is equals to dr over dt, or the derivative of r with respect to time. Okay, so um we have here where r of t is the parametric representation of C. No, so, okay. So writing equation 3 in terms of components, dx, dy, dz, okay, so we get this equation here, no? Since yung position vector natin na r of t is defined by this component dx, dy, dz, so we can now rewrite this equation, or we cannot rewrite this equation this form. Okay, so we have here f1 dx plus f2 dy plus f3 dz, where f1, f2, and f3 are the component of the function f of r along x, y, and z. Okay, so so we see that the integral in equation 3, this one, okay, in equation 3 is a scalar, not a vector, because we take the dot product instead of tangential point of f. So in here, this integral here is a scalar. So we don't need to specify the direction of the whole effect of this integral. It's because we have here the dot product. Now, so we know that from our previous topic, the dot product is a scalar quantity. Okay, so that's why that is a scalar. Okay, so we have here an example. So evaluation of the line integral. So find the value of the line integral when f of r is equal to negative y, negative xy, or it is equals to negative yi minus negative xyj, where negative y and negative xy are the component of function r along x and y component. Okay, so and the path is the circular arc in figure 220, figure 220, so this one. Okay, So from A to B. So it means that we are about to integrate this function here along the path from point A to point B along this path. Okay. So so solution. So we may represent C by R of t, which is equals to cosine of t sine of t or cosine of t I plus sine of t j. So if you take this, if we take the function, okay, of this graph here along the as a function of time, okay, so we can have this function here r of t, okay, where t is from 0 to pi over 2. Then x of t is equals to cosine of t and y of t is equals to sine of t. So um, substituting that function x of t along the function f of r, so we have now this equation. Okay, so by differentiation, r prime of t is equals to negative sine of t cosine of t, or it is equals to negative sine of t I plus cosine of t j. So that by equation number 3, okay, so this one, we are about to using this equation here. By using that equation, okay, so by using that equation and using the appendix 3 na koan, properties, so we can now have this one. Okay, so we have to take the dot product of this function here derived and um, the r prime of t, or the derivative of position vector. Okay, so we have now this one. Okay, so then after that, simplifying this dot product here, okay, simplifying that dot product, so we can now have this equation here. Okay, so then integrating this one individually, no, since we have here the term sine squared of t and the term cosine squared of t are independent of integrating it. So ibig sabihin is we can integrate this one one by one, so we can now have these results here. Okay, so or first kay take muna di kuan itong sine squared of t minus cosine squared of t, kay meron din siyang kuan tawag dito, meron din siyang meron tayong magagamit diyan na ah, tawag dito, identity. Okay, so identity. So noting that cosine of 2t is equal to um uh, no, this one here is equal to this one minus cosine of 2t. Okay, by using the tawag dito, by using the trigonometric identity. Okay, so then changing the variable here, so we have now this one, and that equals this results here. Okay, so this is now the line integral of a certain functions we are having. Okay, so we have also an example here, so please refer on it. So in here naman, ang kuan natin, ang function natin is, okay, or ang path natin is an um, uh, helical arc, no? So yan siya. So we are using that function to take the dot product of a function. Okay? The dot product and the line integral of the certain of a function f of r is equals to zx y, or zi plus xj plus yk. Okay? Where c is this the path, no? As I have mentioned. So same procedure pa rin, we have to use this equation 3 here in order to find the line integral of that one. Then yun, it result to this value here. Okay, so here these are just the simple properties of a line integral. So this is the same as what we have learned from our previous um, mathematics, no, the properties of an integral. So you may please refer to it. Okay, so we have also a theorem here. So, read this one kasi na-discuss ko na to siya. Okay, so other forms of line integrals, we have here f1 dx, f2 dy, and f dz. So, actually, we can evaluate the function, okay, or the integral of the function with their respective components, okay, if meron tayong ganun. But since yung mga examples natin sa taas kay we don't need to express it into component method, so hindi na natin to nagamit. But you can use this one actually. These are the component of the line integral, okay, along x, y, and z component. Okay? So, yun. So, we have here also yung example. So, these are very simple examples. You may refer to it. So, yun pa rin yun siya. So, we have here an important theorem. So, our these are the properties or theorem that tends to define the path, the line integral. So it says here that the line integral 3, yung equation number 3 natin, no? So let me show it again to you, this one. Okay, that line integral based on this theorem 3 um, generally depends not only on the function f and on the endpoints a and b of the path, but also on the path itself along which the integral is taken. Okay, so okay, so it means that um, if you from our previous examples we noticed that um, in taking the integral of a certain function, it is depends on the function f, no? Siyempre nakadepende yun siya sa kung ano yung function natin. Okay, tapos depende rin yun siya sa endpoint. Okay, kasi that serves as our limit, no? So point a and b. Okay? So, without that point A and B, we cannot perform the integral. It's because wala tayong limit. Di ba? So, that's why um, the line integral is fully dependent on these quantities here, the function and the point A and B. Okay? So, nakadepende yan siya. Then, another quantity that the line integral is mostly depend on it is the integral path. Okay? So, taken. What type of path that is taken in order to perform that um, integration. So it means that if we vary the path or the orientation of the path of the arc or the line, no? If we vary its orientation, so the integral will also vary. Okay? So yun yung ibig sabihin ng theorem 2 na to. So it is actually, so it in short, it is path dependence. Okay? So nakadepende siya sa kung ano yung orientation na path ng path natin or kung ano yung itsura ng path natin. So, okay? So, yan. But, may mga function din naman na hindi siya nakadepende sa path, no? So, just as what we have to discuss here, no? So, sabi dito, as before, consider line integrals we have here, same pa rin, ganun pa rin, f of r dot dr. So this integral 1 is said to be path independent in domain D in space if for every pair of endpoints A and B in the domain D has the same value for all path in D that begins in A and at B. Thus illustrated in figure 224. So this is the very specific um, particular examples, okay, of a line integrals in which it is not dependent on and it is not dependent on the path taken. Okay? So sa first na mga examples natin kay lahat 'yon depende sa nakadepende lang sa kung ano yung orientation ng path na ginawa natin to take the integral. Dito kay um, dito sa special case na to, uh, even if we vary the path, no? For example, kay from A to B ka, so dumaan ka rito, dumaan ka rito, dumaan ka rito, dumaan ka rito. The integral of a certain function, okay, along that different path are all equal. Okay, so whether saan ka nag-specify na path from point A to B, so equal pa rin yung path integral natin. Okay, so we call that one sa path dependence, no? Dito sa last natin kay path so it should be path independence, no? This should be path independence. But anyway, a line integral 1 with the continuous f1, f2, and f3 in a domain D in space is path independent in D if and only if yung f natin is equals to f1, f2, and f3 is a gradient of some function f in D. So, kung meron kang function that has an original function in which that function is a gradient of a previous function, so we say that the path integral of that function is a path independent. Okay, so what do you mean by gradient, no? So kung for example kay meron kang function na f, and that function f kay equals siya sa gradient of f, okay, equals siya sa gradient of f. So um and suggest by this equation, so therefore we can say that that function is a path independence. Okay, so we have here an example, no? So you have showed that the integral f dot dr is equals to 2x dx plus 2y dy plus this is a path independent in any domain in space, and find its value in the integration from this point a and b. Okay, so f function f, which is equals to 2x dx plus 2y dy plus 4z dz, is a gradient of function f is equals to x squared plus y squared plus 2z squared, no? So if it means that if we take the gradient of this function f, it will result to this function, ito. Okay, so it will result to this one. So therefore, if we take the path integral of this function, so it is path independent as what we have defined here dito sa theorem na to. Okay, so kung titingnan kasi natin, no? Okay, kung titingnan natin, um if we take the koan, uh, since we have already assumed here that it is a path independent, so if we substitute the point a and b to that function, it will result to this one, same as what we have done if uh, same result as if we try to take the line integral of that function along the path a and b. Okay, so it will still result to 16 pa rin. So that is the definition of path dependent actually. So whether kung ano yung ginamit mo na path in taking that integration, it will result to its value, no? So so in short, hindi siya nakadepende sa path, okay, na ginawa mo or ginamit mo pang integrate. Okay? So, we have also here an additional concept regarding on the path independent na cases. So, please read this one. We have also here an example that results to that. So, these are very important examples, no? So, please read that one. So, yun lang actually yung pinaka summary, no? So, once again, no? If meron kang function that and that function kay ginawa you take its path integration along a certain path, okay, so that function, well, in general that function is path dependent, nakadepende siya sa kung ano yung path, nakadepende siya sa kung ano yung path na ginamit mo in taking the integration. But if that function has an original function which which has been derived, no, by using a gradient, so ibig sabihin kay kung yan yung kung yung function mo kay may original siya na form, okay, uh, may original siya na form, then if you take its line integral, so it will be independently to that path. So whether you choose a different path in taking that integration from point A to B or from the initial point to the final point, so the value is still equal pa rin. Okay, so yun lang yung pinagkaiba ng dalawa. So I think that's all. So if you have any question regarding our topic today, you may ask it to me right away. Uh, so that's all. Assalamualaikum warahmatullahi wabarakatuh.